So now we are dealing with confidence intervals for proportions. So yesterday versus the day before, what was our difference? Yesterday versus the day before, what was the difference? Z versus T. When do we use? You don't need to write this anywhere. When do I use Z? When do I use T? So when I get two proportions, what do I not have? Ever. Sigma. So am I going to get down to the situation of I have to figure out if it's known or not? No. So we don't deal with this process when we get to proportions. We always deal with Z. So proportion is going to always deal with Z and never going to deal with T. So don't use T star for proportions. Alright, so yesterday, the day before, what variable are we estimating? Like the whole problem is our goal is to find what? Mu. Today our goal is we're estimating what? We're estimating P. So we only know what? We don't have sigma, we don't have S, we don't have mu, we don't have P. Of those, the only thing we have is P hat. So when I'm using Z star and my sigma is known, what is my standard deviation of the statistic? What is sigma of X bar? When I use T instead, I have to use what instead? What is this one called as opposed to this one? Standard error, because I had to estimate one of my parameters. Back in chapter 7, what is that equation?
Which one called standard error?
Because that is a statistic. We had to estimate it. What is my equation for this? Why is that an issue? We don't know P. So that's our whole goal is to estimate P, so why would I plug in P there? So even here, I have to use what instead? Which means, just like up here, we're going to call this what? It's standard error because I'm using a statistic there instead of a parameter. So our formula for confidence interval for proportions, what was our equation? Let's say if we're using this one, this top line. What is our confidence interval equation? From the homework we just did. If I were doing this kind of problem, what's my do equation?
Plus or minus Z star times standard deviation.
And I could rewrite this one out too, that's fine. Now what am I going to put instead of this?
P.
P hat. What am I always going to put here? Z star. What am I going to put here instead? That equation. So, yes, we're starting with a new problem. Yes, we're dealing with a different parameter that we're trying to estimate. But you should pretty much know how to get through this whole process before I ever tell you. Based off of the 2-minute conversation we just had. And just making sure we understand wording, context up here. What part of that equation is considered margin of error? Starting where? Everything after the plus minus. What part of that is considered standard error? Everything but the z. So it's the standard deviation part, but we call it standard error because we're estimating a parameter within the standard deviation section. Alright, so what is our method going to be? How many samples are we going to do? Still one sample. Now it's always going to be a, are we still making an interval? And now it is for what's my big thing that I have to do with random? Differentiate between selection and assignment. Is that going to change?
I had a question about that. Can you explain that?
Is that going to change? Just because I know proportion, is this random selection going to change? No. I'm just going to put up here, put same. So if I am doing an experiment and I take, like I split this group in half and I make half of you do placebo and half of you do a treatment, then that's random assignment. So it'd have to be like through an experiment to do that. So it shouldn't, like right now, you're probably like, oh, I don't know if I'll catch it, but it should be really obvious when we get to one.
So right now,
It just doesn't come up that much
right now, selection.
I mean, we could have one in there.
Mhm.
We just don't deal with experiments right that much. Alright, so is independent going to change? Still 10% condition. Still need to be at least 10 times. This population needs to be at least 10 times sample. Does that change some proportion? Sounds good, right? Same. Now, normal condition does change, just like it did in chapter 7. It's been a while since we've dealt with this. What are my 3 ways to check for means? For normal? Stated, central limit theorem, or histogram. That is not the case for proportion. I check what instead? But that should be an issue. Why? We don't know P, we can't use P, which means we're going to use what instead? So would it always be better to use the parameter or the statistic? Parameter. But if we can't, then we have to use the statistic. Like that's kind of the broad across the board for the next couple chapters. And then I don't need you to write much here. Write those out in context because we're going to write them on a different sheet of paper. And always so we can. So I always have people ask about this. Well, if it's a 4-step and it doesn't work, how would I know what to do, or what would I do at that point?
Like if it was random.
Mm-hmm. This is the kind of way I would ask the question. So these questions, the only thing I say is in each of these settings, check whether the conditions are met. Explain the conditions that are not met. Usually I wouldn't. I actually added this in, and I think I typed it on your paper, just so we don't have to write as much because we don't have much room. Usually you would say check all conditions and state why they are or are not met. But what are my 3 conditions? What's my first condition?
Random.
What's another one? And my last one, because I rewrote this to say, explain the ones that are not met, I'm only going to talk about them if they didn't work. Random yes, no. Because where's our selection process here? Is that a good sample of everybody in the school? No, not at all. So, what kind of sample is that? What's a good answer for what kind of sample is that? Convenience. Is that group going to be biased? Yes. There's something that's going to be very similar about the first ones who are here as opposed to the ones who are not the first ones to get here. Normal, what would I check here? So, there are 100. That's my N. What do I do with that? So what's P hat?
17.
So, thinking through this,
That's just 17.
so in words, this is actually always our what?
Just
Number of successes. And most of the time in this kind of problem, it's going to give it to you. So would I need to go through all of this to figure out that? So like these, we're going to go straight to n times p hat equals 17. We're not going to like show all the work in between. Because otherwise you're just going backwards for no reason.
Okay, so it'll always work out like that.
Mm-hmm. So then, how would I know in this problem what that is? So I had 100, 17 of them were successes. So 83 are left for failure. So it's usually not going to give you both, you just have to find the other one. And both of those are greater than or equal to 10, so then I don't have to state why that didn't work, because it does. I've checked through it, I just didn't write it all down. Independent, 10% condition, n times 10, 100 times 10 is 1,000, so we would have to say what? There are at least 1,000 what? Students at this particular large high school. So that seems like that would work. So random is the reason why this one doesn't work. That one's pretty straightforward here. We don't have to write a whole lot.
So like for like B, right? I'll wait.
All right, so same thing here. Again, if I actually asked you a question like this on a test, you would need to write out your work for all three of them. But I'm giving you this much space to do it, so I'm trying to do it to where we can do everything but without. I asked it to where I only checked the ones that weren't met. Random, yes or no?
Yes.
And if we had to write that out, we would write stated random sample in parentheses, random selection, normal.
So the thing would be 3.
So this is where we would actually need to write it out. So n times p hat gives me what? N times 1 minus p hat.
22.
So 3 is not at least 10. You should write words there, but there's a reason I don't want you to write. I always go and talk about it. I was very funny about this kind of problem for chapter 7 with saying n times p, as far as what you wrote this part as. Shouldn't have any issues there. What would actually go here?
But I thought there were at least 10 pages.
Sorry, I'm writing it theoretically. They're not. You're right. theoretically, what would go here? Successes and failures, and then what? So I don't write what I'm writing in red right now. For what? Or in what? So in general, what would it be?
Population.
25.
This should make sense because when I actually did my sample had 3 successes, right? But in chapter 7, that's really weird because I'm saying my sample, but I'm using my population proportion. So it would actually be, theoretically, we would assume that many were in the sample, and it gets really confusing, and I kind of glaze over that on purpose because it's easier to talk about here. And I wrote on your tests, should be sample there, but I didn't talk about it. Do you see why this one makes sense? Because that's literally how many were in the sample. So you need to say this as the sample, which I'm going to write in our generic 4-step. But now let's finish writing this one out.
The sample was 3? The sample was 25.
The successes in the sample was 3.
But the
The sample was 25. So what is this one? Too much salt? And exact opposite, so not too much salt.
But then if it worked for one and not for other, do we still write both of them here?
So I'm going to do like no with this one, yes with this one. That's why you don't actually finish writing this out if it doesn't work. So I'm just kind of thinking through it. Chip bags in our sample. So we cannot use normal approximation. So now do you understand, because I've talked about this, I've answered your question theoretically every time I've been asked about it. So now do you understand if it doesn't meet a condition, then what it would actually look like? I won't say do a 4-step. I would say, okay, here's a whole scenario. Now tell me if it would or wouldn't work and why. And so it would be one that would just stop here. So I wouldn't try to make you think that it's a 4-step. If I asked you or the AP exam asked you and you think it looks like a 4-step, we're not going to have you stop and state or plan. All right, go ahead and get out the,
This one is
independent would be 10% condition, 25 times 10 is 250, and it says there are thousands of bags filled in an hour, so it gave you that was going to work. So normal is the only reason it didn't work.